Hey everyone, today we're going to be working with face detection using OpenCV. So on this random image that I stole from Wikipedia, there are four individuals on the screen. Three of them are facing to the front, and the woman is looking down. There's an algorithm detecting the Viola Jones algorithm. I'm assuming is detecting their faces as it's best at detecting frontal faces. Facial detection is not to be confused with facial recognition, which is a step further in not only noticing that there are human faces here, but discerning who the individuals actually are. So we're going to write a short bit of code in Python OpenCV using the same algorithm to detect faces that are coming in for the webcam. So whatever you're doing, self-driving car, security system, you can use OpenCV. They have a bunch of training data and a lot of awesome stuff. So not only do they provide an implementation of the Viola Jones Haar Cascade classifier, they also provide training data. So very briefly, how everything works is um, OpenCV provides this training data. So the training data, the algorithm is trained on the data. So for instance, for faces, there are going to be thousands of positive images, which means there are thousands of images that contain frontal faces. And then there are thousands of negative images. Those are images that do not contain faces or frontal faces. So their algorithm's trained on the data, and it's able to output where the faces are in the image. Not only does can the Viola Jones algorithm be used for faces, but it can be used for all types of objects. And OpenCV provides right out of the bat training data for Russian license plates, faces, eyes, and of course cat faces. Gotta make sure we have cats in this database. Um, so before you actually use any of these, especially if you're doing it for commercial use, be sure you check out the files and look at the comments. There's some of them have licensing, some of them talk about like this one's by Intel, some of them talk about limitations of the training set. But feel free to use them, but be sure that you're aware of what the restrictions are. So let's go ahead and get to the code. So here I just have some starter code. It's reading in the frames that are coming in from my webcam. So what we're going to do is modify this code to make it so that for every frame that comes in, we are actually detecting the faces in the frame. So first thing first, we're going to use um, the file that we downloaded. Use the file that we downloaded, this Haar Cascade um, classifier, this training data, and we're going to load that in. So I'm going to use the CV2 Cascade Classifier, and it takes a string of text, which is the location of the training data that we're going to use. Um, so we got that. Um, Once we've loaded in our image frame, we have it in grayscale. Right here, what we're going to do is let's get all the faces that the classifier is able to find by using the function detect multi-scale. Um, so it takes the image that we're looking for, it takes the scale parameter, and it takes the number of neighbors. I'm not going to get into those last two parameters in this video because it will require me to explain a bit more of the algorithm, but I'll do another one for those of you who are interested in more in depth in what's going on. So for right now, to get started, you can just use 1.3 and 5. You'll see it on the tutorials and in the docs. So just to show you what's going to happen with that, I'll print out I'll print out faces for every frame, just so we can see step by step what's happening. Um, so there's my face, and so what it's doing is it's printing out the location that it's seeing faces at. But it's no fun because we don't see the computer actually detecting faces. Um, so what we're going to do is for every it's returning CV rectangle. So for every rectangle we get, we're going to get the location X and Y and the width and height in this faces array, and we're going to draw a rectangle um, over the location. So we're using the frame image that we have. We're taking this X and Y location. That's going to be the 1 point of our rectangle. We're going to take the X and add the width. And we're going to take the Y and add the height for the next point in our rectangle. I think this is going to be a blue. I think this means it's going to draw a blue rectangle, and it'll have a line width of 2. So we have our faces, and for every face location we have, we're going to draw a rectangle around that location. And so hopefully this is right the first time. So I'm going to run it again, and you can now see my face on the screen. Notice there's a painting in the background, there's a chair, and it's not disturbed by the other objects in the background. Um, so there are more parameters that you can. They're the parameters that you can tune that we kind of I talked about really quickly, but I didn't say anything about them. The scale factor and the neighbors. There are other parameters in the detect multi-scale function, and there are other things that you can do. Not only can you use the pre-built training data, the classifiers, you can also use OpenCV to build your own classifier, and we'll go through that in another video. So now that you know how to detect people, go ahead and make your self-driving car, your security system, or whatever awesome thing you're doing. I'll check you out next time.